Alright, today we're going to be talking about and working with polynomial functions. Polynomial functions and standard form of polynomial functions. And looking at a function and determining what movement the graph will be making. So, let's start off with some definitions. And a monomial is a real number, variable, or product with whole number exponents. The degree of a monomial is the exponent of the variable. A polynomial is a monomial or sum of monomials. The degree of a polynomial is the greatest degree among its monomial terms. Standard form of a polynomial function arranges the terms by exponent in descending order. You can classify a polynomial by its degree or number of terms. Alright, so now we're going to build this little table that has headings: degree, name using degree, example, number of terms, name using terms. Alright, so a polynomial with a degree of 0. If you name it by its degree, it would be called a constant. An example of a constant would just be a regular old number. The number of terms would be 1. And the name using terms would be monomial. A degree of 1. Name using degree is linear. An example would be x plus 4. The number of terms in this case would be 2. And if you were naming it by terms, it would be a binomial. A degree of 2 is a quadratic. An example would be 4x squared. This is another example of one term and a monomial. Degree of 3. Name would be cubic. Could be something like 4x to the third minus 2x squared plus x. The number of terms in this case would be 3. Three terms is a trinomial. A degree of 4. Quartic. An An example of that could be 2x to the fourth minus 3x to the third plus 2. This function has 3 terms and is also called a trinomial. A degree of 5. If you were naming a polynomial with a degree of 5, you would name it quintic. And that could be something like x to the fifth plus 3x to the fourth plus 2x squared minus 1. This has 4 terms. And if you were naming it by terms, it would be a polynomial. Of 4 terms. Alright, so this degree comes from the largest exponent. Okay? In a quadratic second degree, the largest exponent in the polynomial is 2. Linear, this x right here is raised to the first power, but it's implied, it's not written. Okay? This 5 that's right here, that 5 is the same as 5x to the 0. Okay? But the x to the 0 is equal to 1. So this would be the same as 5 times 1, which would be 5. So this x to the 0 doesn't get written. And again, it's implied. Oh, where'd my marker go? That x to the 0 is implied. That's why this 0 degree is a constant, and it's the same as 5x to the 0 power, but it's just written as 5. Alright, so in the first part of your assignment today, you're going to write each polynomial. In standard form. Classify by degree and number of terms. So if this is your given, alright, say we're given 3x plus 9x squared plus 5. Alright, we need it in standard form. And then we need to classify it by degree. And by terms. So we rewrite it with the exponents in descending order. So in standard form, this is 9x squared plus 3x plus 5. If we're classifying this by degree, Alright? If 2 is our highest exponent, then this is quadratic. And it's got 1, 2, 3 terms, so that makes it a quadratic trinomial. If we're given 4x minus 6x squared plus x to the fourth plus 10x squared minus 12. In standard form, we're going to go back to descending order of the exponents. So this x to the fourth goes first. Now there's nothing x to the third, but there is a negative 6x squared and a positive 10x squared. So you would combine those two terms. That becomes positive 4x squared. And then you've just got a positive 4x, and you got a negative 12. Alright, so when we classify this by degree, our highest exponent is 4. So that's quartic. Alright, and we've got 1, 2, 3, 4 terms, so this is a polynomial. Of 4 terms. Y'all get the idea? Let's do a 3x to the third minus x plus 5x to the fourth. In standard form, we got 5x to the fourth plus 3x to the third minus x. By degree, we're quartic again. And by terms, in this case, we've got 3, so we're another trinomial. Alright, so that's writing polynomials in standard form and classifying them by degree and by number of terms. Now, why you do all that is for this. The degree of a polynomial function affects the shape of its graph. And determines the maximum number of turning points. or places where the graph changes directions. It also affects the end behavior. Or the directions of the graph at the far left and right. Okay, we're going to say a function is increasing when y values increase as x values increase. And is decreasing when y values decrease as x decreases. Oh, take that back. And decreasing when y values decrease as x values increase. Alright, so here are some examples of what some graphs may look like based on the polynomials being in standard form. So we're going to take something like y is equal to 4x to the fourth plus 6x to the third minus x. Alright, this graph would look something like this. This end behavior is referred to up and up. The number of turning points Alright, here's the turning point. Here and here. It's where the graph changes directions. This graph has 3 turning points. Y equals negative x squared plus 2x. Hopefully we recognize that as a parabola. Parabola that is going down since its a value is negative. Alright. In this case, this end behavior, that's down and down. Turning points. Alright, we got one right here. One turning point. Y equals x to the third. That graph looks like this right here. This end behavior. This is down and up. Turning points. In this case, there are 0. Alright, the graph doesn't completely change directions. Alright, and then let's take a look at one more example. We got y equals negative x to the third. Plus 2x. That graph would look something like this. End behavior. This is up and down. And hopefully you're seeing how we determine the end behavior. We go from left to right. What's going on the far left of the graph? Right here it's going up. Far right of the graph it's going down, so your end behavior is up and down. Over here on this example, our end behavior, we start on the far left, it's going down, and we work to the far right where it's going up, so that's a down and up end behavior. Alright, we got turning points on this last example. Turning points. Got 2 of them. Got one right here and one right here. So we got 2 turning points. Yeah.
What was the equation for the down?
For down and down,
Yeah.
Negative x squared. Alright, so here's a little table for you to put in your notes. End of behavior. When ax to the nth power is the leading term, Alright, if the a is positive, and the n is even, we got up and up. If the a is positive, if the leading term is positive, but its exponent is odd, if n is odd, then we got down and up. Alright, a is the term, is the number in front of the leading term. N is the exponent of the leading term when it's in standard form. Alright, so if your a is a positive number and your exponent is even, the end behavior is up and up. If your a is positive but your exponent is odd, then your end behavior is down and up. If your a is negative, if your a is negative and your exponent's even, we go down and down. And if your a is negative but your exponent is odd, then our end behavior is up and down. Alright, so all of this end behavior stuff is determined by the leading term, the a value, and this n value or exponent of the leading term in standard form is what you use to determine how this graph, or what the end behavior of this graph will be. So we're going to take a couple of examples here, and we are going to what is the end behavior of each function. Alright, so if we take y equals 4x to the third minus 3x, alright, we're looking at our a first, and in this case our a is positive, alright, but our exponent is odd. So here's positive and odd. So this is end behavior is down and up. Okay? If y is equal to negative 2x to the fourth, don't do that. Plus 8x to the third Well, just look at the negative 2x to the fourth while you got it, right? And your a is negative, right? Your a is negative and your exponent is even. What we got for that? A is negative. Exponent is even. Down and down. Good. Alright, so that's all we're covering today. I know it's a lot of writing and it's a lot of information, but it's pretty important as far as Algebra 2 goes anyway. Alright, so your assignment for today, whether you can see the wall or not, we're going to go page, I got a handout for you, page 285. And today we're going to be doing 8 through 31. 8 through 31. Be sure that you check focus for homework as well.